Hello students, I am Dr. Abhijit Shah from Chemistry Department of SRMIST. I am taking BTech Chemistry course. In this lecture, I will describe the XPS. That is full name is X-ray photoelectron spectroscopy. It is a part of your BTech syllabus. In module 5, we generally discuss this XPS technique. So today in this lecture, I will talk about this XPS. You will learn the principle of XPS technique, you will learn the application of XPS technique, and you also understand the mechanism behind this XPS technique from this lecture. So first, uh, we have to know what is photoelectric effect, because XPS technique actually depends on this photoelectric effect. So we know that if we have a metal surface and if we apply electrons, photons, or high energy radiation, high energy electromagnetic radiation, in high energy electromagnetic radiation there is a photons. So when these photons hit on a metal surface, it emits the surface electrons, not the core electron, it emits the surface electron. So this emitted electron, so this phenomenon is called photoelectric effect. So photoelectric effect is the emission of electron when electromagnetic radiation or light, it should have high energy electron, not low energy electromagnetic radiation. High energy electromagnetic radiation, when hit on a surface, it emits photoelectron. The emitted electron is called photoelectrons, and this phenomenon is called photoelectric effect. In photoelectric effect, we have one equation. Equation means, so we know that principle, that conservation of energy, right? So the amount of energy present in the incoming electromagnetic radiation, that energy will be distributed in the electrons. So if the energy of incoming radiation will be h nu, and that h nu should be equal to the kinetic energy of the emitted electron and work function. What is work function? Work function is the minimum energy required to remove the electron from metal surface. Okay, so work function is the minimum energy required to remove the electron from the surface, that is called work function. Okay, and kinetic energy is the, so when electrons are emitted, it has some velocity, so it has some kinetic energy. So kinetic energy of the electron, it will be half mv square. So kinetic energy of electron plus work function will be equal to h nu. It means the amount of the energy here is coming and hitting on the surface, it is distributed the electron, it removing the electron from the surface, and it provides kinetic energy to the electron. That is the photoelectric effect. Now, why we have to know about XPS? What is the importance? So XPS, I already told, it is based on photoelectric effect. And X-ray, we are using X-ray. I told na, high energy electromagnetic radiation. So X-ray is a high energy electromagnetic radiation. Okay, so because of that we are using X-ray, and the name is X-ray photoelectron spectroscopy, or XPS. So this technique can identify the element that covering a surface. It is actually surface analyzing technique. So this technique can identify the element. So in our surface, what are the elements present? What are the metal present, or what are metal means there can be different type of metal: aluminum, iron, gold, copper, silicon. Silicon is no, not silicon. Silicon also we can detect from XPS. So what are the element present? Not metal. What are the element present on a surface? We can detect by XPS. Not only that, we can also detect the chemical state. Chemical state means is it in plus of 1 or plus 2 oxidation state? That also we can identify. We can also detect the overall electronic structure of the material from this XPS technique. So basically we can analyze the chemical composition of a surface by this XPS technique. Because of that, XPS is called electron spectroscopy for chemical analysis. We can analyze the chemical composition. Because of that, it is called electron spectroscopy for chemical analysis. Next is by XPS we can differentiate different type of chemical environment, different type of bonding. For example, silicon oxide bond and carbon silicon bond. This type of difference we can detect by XPS. We can also detect the oxidation state, whether the element on surface is +3 or +2 or +4. We can detect by this XPS technique. So we can identify iron 2 plus versus iron 3 plus. We can identify titanium 3 plus versus titanium 4 plus by the XPS technique. Next, what X-ray does. So what is the role of X-ray? First, so X-ray is the main role in XPS. It is providing the energy, which that energy heat means it is the electromagnetic radiation that hits the core electron, means it hits on the surface. Okay, when it hit on the surface, so there the surface there are the atoms. The core electron of the atoms they are removing, right? And this X-ray penetrate. Let's say on a surface there is a layer of some compounds or some thin layer of some compounds. So in surface, the thin layer of the compounds it can be penetrated by the X-ray. So by this XPS technique, we can also calculate the depth of a surface. Okay. Another thing. Okay. So another thing, in XPS we are using a single monochromatic X-ray radiation, means single energy X-ray radiation. So there is a two type of X-ray we are using. One is magnesium K alpha, another one potassium K alpha. Magnesium K alpha has energy 1253 electron volt, and aluminum K alpha has energy 1486 electron volt. So these are the XPS source, means X-ray source we are using in the XPS instrument. Another thing, in XPS, the signal, whatever the signal we are getting, whatever the electrons is coming out from the surface, it is around, the depth is around 10 to 100 angstrom of the surface. Okay. So what is the role of X-ray? Role of X-ray is we are using monochromatic X-ray radiation, and it hits the electrons of the atom present on the surface, and because of that, electrons are emitted. And also X-ray can measure the depth of the thin layer present on the surface. Okay, now how does XPS work? Okay, so first step is electron in the sample absorb the enough energy from the X-ray radiation. So X-ray radiation has some energy. So electrons on the surface it absorb the energy. Now if the amount, so once electron absorb the energy, so then if the energy is more than the work function, then electrons will be ready to emit. Now if the energy is more, that energy will be converted to, that energy will give electron to some kinetic energy. So electrons are emitted from the sample with specific kinetic energy. Okay. Then there will be one detector. That detector analyzes the energy of those ejected electrons and plot those energy and relative number of the electron. Okay. So first electron is coming, atoms present on surface absorb the electromagnetic radiation, means our atoms present on the surface they absorb the electromagnetic radiation. Because of that, electrons of those atoms they are getting that energy, and after getting that energy, that electrons are emitted, and there will be one detector or analyzer that actually analyze the emitted or ejected electron and plot this emitted energy of this electron and the number of electron. So electrons of different energy follow different path through the detector. Okay, so I will tell you this part. In that instrument there is a electron analyzer that electron analyzer, or I can say there is a person, let's say they are not person, there is a method that can analyze, that can identify the speed of the electron, the energy of the electron. Like in our road, there are camera which can measure the speed of a car. Similarly, in the instrument, there is a part of inside the instrument which can detect the energy of the electron. Based on that, there is some valve. Based on that, electrons are allowed to go to the detector one by one. Okay. Now, what limitation is there here? So XPS can detect. XPS cannot detect for hydrogen helium. Means XPS can easily all element except hydrogen and helium. Okay. For hydrogen helium, we cannot apply this XPS technique. First limitation. XPS technique is a very good technique, but one limitation is for hydrogen and helium, we cannot apply this technique. Second limitation is it needs very high vacuum. Why? Because when electrons are moving through a path, now in that path, if there are air or other gas molecules, so electron will hit that gas molecules and then it will not reach to the detector. Because of that, the path should be clean. How it is possible? It is possible by keeping the instrument in the high vacuum. To get this high vacuum, means 10 to the power minus 6 Pascal, we need very high vacuum pump or ultra high vacuum pump. Okay, those vacuum pump give pressure around 10 to the power minus 6 or minus 7 Pascal. Next thing is, I told that already that XPS can measure the depth of the sample. So a surface, in surface means it has 3 atomic layer. Okay, and thickness will be 1 nanometer. Now if there are thin film, okay, thin film, it will be 1 micrometer, very big. If there is ultra thin film, there will be 10 nanometer. Means in surface, we can say there are some layers. If we make some thin film, there are some layers. So depending on the depth of the layers, we can divide in 3 categories. One is only surface, which is has 3 atomic layer, ultra thin film 10 nanometer, and thin film 1 micrometer. Okay, and this surface atom property and bulk atom property will be different. Why? Because in bulk, if there is some atom, it is surrounded by other atoms. But in surface, when the atom is present, it is surrounded by 3 directions. But in one direction, there is no other atom. So bulk, so electron of the bulk atom cannot remove, but electron on the surface atom can be removed. Okay. So this is what I said. So bulk material, this is thin film, this is ultra thin film, and this is surface. Surface means a layer of 3 atomic layer. Thin film 1 to 10 nanometer. So ultra thin film, and thin film green one 10 nanometer to 12 micrometer. Okay. So when X-ray radiation hit, it emits electron from the surface, not from the bulk. Why? Because in bulk, atoms are surrounded by other atoms. So electrons are surrounded by all other atoms. Because of that, electrons cannot be removed. But in surface, it is surrounded by 3 directions. One direction is free. So electron can be removed from surface. Okay, next, mechanism of electron ejection. Okay. To understand the mechanism of electron ejection, first thing is we have to know the electron distribution in an atom. So when we have an atom, we know in atom there is some shells, K shell, L shell, M shell, N shell. Right? Now each shell there is some orbital, S orbital, P orbital. So in K shell there will be only S orbital, 1s orbital. In L shell there will be S orbital and P orbital. Now S orbital can contain maximum 2 electrons, and p orbital can contain maximum 3 electrons. Okay. Now, for example, if we take one atom having this number of electrons. So in K shell 2 electron, L shell 2 electron, L1 shell means 2s orbital, and L2 and 2, 3 shells, there is 2p orbital, there is 6 electron, right? So these are the orbitals is occupied by electron. So this orbital is called valence band. Okay, and after this, the orbitals where electrons are absent or vacant, it is called conduction band, right? Valence band, conduction band. Now, in between valence band and conduction band, there is one level. That level is called Fermi level. Okay, so Fermi level is the highest energy level that an electron can occupy at absolute zero temperature. So what is Fermi level? Fermi level is the highest energy level that an electron can occupy at absolute zero temperature. The Fermi level lies between valence band and conduction band. Okay. Now, so Fermi level has some energy. Vacuum level. So what is vacuum level? After conduction band, there is one level that is called vacuum level. So vacuum level has energy. So work function, what I said before, work function is the amount of energy required to emit the electron. Now, if we specify more, so if we want to specify the work function much in detail, so we have to say that work function is the amount of energy required to bring the electron from Fermi level to vacuum level. Okay. So before what I said, in general way, work function is the amount of energy required to bring the electron from surface, right, to overcome the binding energy of the electron. The amount of energy required, that is the work function. Now, if we specify in much detail, so then it will be work function means the energy of the electron required to bring the electron from Fermi level to vacuum level. Okay. Now, what is binding energy? Binding energy is the minimum energy required to electron from an atom. That is very simple. Now, this binding energy is proportional to obviously atomic number and the distance from the nucleus. Now, electron can be removed only when the incoming radiation or incoming energy can overcome the work function, can overcome the binding energy, work function, and provide the kinetic energy to the electron, right? So, when an electron will be removed? Electron will be removed when the incoming radiation has ability to provide the binding energy of the electron, work function of the electron, and uh, providing the kinetic energy to the electron. Then only electron can be removed. Okay. So what will be the equation? This is the equation. So H nu should be equal to binding energy of the electron, work function, and kinetic energy, right? So this energy is called the energy Fermi level, energy in the vacuum. So work function means this one, bringing the electron from Fermi level to vacuum level, and after that is the kinetic energy. So energy of the incoming radiation, incoming X radiation should be equal to the binding energy plus work function plus kinetic energy, right? Now from XPS, so we determine this, okay, we determine this kinetic energy of the electron, right? In XPS instrument, I told there is a camera, let's say camera. They can calculate they can see the electron and calculate its kinetic energy, right? So in this equation, what are the unknown things? So H nu is the incoming radiation, we know very well, right? H nu, and work function is depends on spectrometer. It depends on spectrometer, depends on the element what we are using. Binding energy is also right. So H nu, no, work function no. Kinetic energy we are calculating from the instrument. Then we can, if we know these three things, we can easily calculate the binding energy. So binding energy of an electron of different element will be different. Some element very high binding energy, some element have low binding energy. So based on this binding energy, we can identify the element. Okay. So from XPS technique, we can only calculate the kinetic energy of electron. Other these two things are known. So we can, based on the equation, we can calculate the binding energy of the electron. If we know the binding energy, we can easily identify the element, because binding energy of different element will be different. So already written these things. Now, okay, kinetic energy measure in the XPS instrument, H nu photon of the incoming X-ray radiation, work function, it's specific to instrument, binding energy we calculate, right? Okay. Now this is the standard diagram of an XPS instrument. You can see, so there is the sample. Okay. So first there will be X-ray source, potassium K alpha or magnesium K alpha is using X-ray. After that, there will be some ion gun, argon gun. What is the reason? It is required to clean the surface. Means, let's say sample 1 finish, analyze and finish. After that, we have to remove the sample properly. Simple wiping is not able to remove the sample properly. So we need chemical method. For example, argon ion gun. So argon ion gun will heat the surface and clean the surface properly. Okay. Also, this argon ion gun also used to check the profile. To check the profile. Profile means depth profile of the sample. Okay. Next, there will be some camera for optical imaging. To optical imaging, why required? To align the sample, to focus the sample. So we need this camera. After that, we are coming this electron collecting lens. So when X-ray will hit the sample, electron will be removed. So we have to collect this electron. So this is the electron collecting lens. It will collect the electron and focus. After that, there is electron retarding lens. It will decrease the kinetic energy of the electron, and then it will throw the electron to this electron analyzer. So this electron analyzer filter the electron. I told you there is a camera which can check the kinetic energy of the electron. So this electron analyzer can filter based on the kinetic energy. It can see what is the kinetic energy of the electron. Based on that, it can send to the electron detector. So one by one, say let's say there is 100 electrons is coming. Now 10 electrons having kinetic energy 5. Another 20 electrons kinetic energy 4. So let's say it will send first 10 kinetic energy electron to the detector. The detector will get the signal. And signal x-axis, it will show the binding energy. Okay. And y-axis it will show the number of electrons. Right? If signal is much intense signal, means there is more electron. Okay, so like that we are getting this graph. Okay, we are getting this binding energy in x-axis. We are getting signal in the means number of electron in the y-axis. Okay, so from this, if we know the binding energy, we can identify the element. So this is the XPS technique. I hope you have understood. Okay, so what is the important thing? Important thing is the principle. You have to talk about this X-ray photoelectron spectroscopy principle, means that photoelectric effect. You have to know this instrument diagram. What are the main component of instrument diagram? You have X-ray source, argon, ion gun, electron accepting lens, electron retarding lens, electron analyzer, detector, right? And most important thing in the instrument is kept in a high vacuum, ultra high vacuum, 10 to the power minus 5, 10 to the minus 6, or 10 to the power minus 7 Pascal. Okay, all those things are very important. I hope you have understood. Thank you.